Good morning, Mrs. Patton here. It's Tuesday, March the 31st, 2020, and today we're going to be talking about Gay-Lussac's law. I hope you have your digital chemistry notebook ready to go, and let's go ahead and get started. Oh, you know cats. You get settled in and ready to work, and they pop up where they shouldn't. Here's Flurfnurget posing all pretty for her profile picture. Doesn't she look nice? Oh no, how many times has this happened to you? Your profile picture is so nice, and then someone tags you in something like this. Flurfnurget, it'll be alright. When she's not assisting me with teaching, she likes to co-pilot when Mr. Patton plays video games. You can usually find her on the top of my chair with a perfect view of his computer screen. Alrighty, back to our notes. Joseph Gay-Lussac was a French chemist who lived from 1778 to 1850. Gay-Lussac's law deals with pressure and temperature. Our units of pressure can be atmospheres, kilopascals, millimeters of mercury, and torr. Don't forget the units of temperature are going to be Kelvin and degrees Celsius. Now, since my variables are pressure and temperature, this means that volume is going to be held constant. It is not a variable. This law states that as temperature of a gas increases, so does the pressure. The temperature and the pressure are doing the same thing. Do you remember what that's called when they do the same thing? It's a direct relationship. When the temperature increases, the pressure increases. When the pressure goes down, the temperature goes down. It's a direct relationship. Our equation for Gay-Lussac's law is P1 over T1 equals P2 over T2. Don't forget, pressure is P and temperature is T. Our volume is held constant. Our real-life example would be firing a cannon. When the spark is lit in a cannon, the gunpowder is going to increase in temperature. And let's think about what this law says. As the temperature is increasing, so is the pressure. Until it reaches the point where you get boom, big explosion. Example 1. If a gas at 740 millimeters of mercury and 70 degrees Celsius has its pressure lowered to 720 millimeters of mercury, what will its temperature be if the volume remains constant? I've listed my variables down the side. Pressure can be torr, millimeters of mercury, kilopascals, and ATMs, atmospheres. Let's see what's in this problem. 740 millimeters of mercury. So that's my P1, my first pressure. Okay, and it says it's lowered to 720 millimeters of mercury. So that is my P2, my second pressure. So we have our pressures. Let's look for our temperatures. 70 degrees Celsius. Now remember, for our gas laws, we don't really like to use Celsius. We're converting this to Kelvin. Celsius plus 273 equals Kelvin. So 70 degrees Celsius is 343 Kelvin. Our question says, what will its temperature be? So we don't know our T2. It's our X. Okay, so there's our X. It would help if we write the equation. It's P1 over T1 equals P2 over T2. That is Gay-Lussac's law. We know all of these variables. All that's left to do is plug them into the equation and solve. So our first pressure is 740 over our first temperature, 343, is equal to 720 over x. Cross multiply and divide, and x equals 333.73 Kelvin. Okay, so that wraps up the notes for the chemistry digital notebook. Let's look at the next two slides after the notes. In your digital notebook, I've included a YouTube tutorial to help you figure out how to use Pic Collage if you've never used it. A lot of you probably already know how, but just in case. And I want you to make a digital infographic on how a hot air balloon works. The video was in your digital notebook for yesterday. So if you missed that, go back, scroll up some in your notebook, and watch the video on a hot air balloon. Answer some questions. What are the gas particles doing? What does the volume, temperature, and pressure do? Which gas law does this cover? As you have the whole world at your fingertips. So if you can't figure it out, look it up. The very last thing I want you to do today, on this slide, I want you to list each gas law, the name, and the equation. Now, I know there's a couple we haven't covered yet. I've added a cheat sheet in Google Classroom. I want you thinking ahead to what the things in the equation mean based off of your knowledge of gas laws so far. All right, guys, feeling a little bit nostalgic. Miss your faces so much. This is a picture I took earlier this year. Some of the wonderful artwork you guys had been leaving on my board at the back of the room. I miss those notes and those polls y'all would have for each other. I've really enjoyed having you guys this year. I know it's hard right now. Keep up the good work. Know that your teachers love you, we miss you, and stay safe.